GIS is represented in form of raster and vector. Raster is geographic feature like land cover represented as single square cell. Vector, these are the features which are represented in form of points, lines and polygons. Attributes are the values stored in RDBMS, represents record of each feature. This slide shows how real world is transferred to raster and vector. So from this picture we can see data in raster format are divided into cells, pixels or elements. Cells are arranged in arrays. Each cell has a single value. Row and column numbers are used to identify the location of the cell within the array. Digital image is a common example of raster data. Image gets pixelated when it is zoomed in. The right hand side image is a vector format. Data is created using points, lines and polygons. Points are located by coordinates. This could be centroids, cells, etc. Lines are described by a series of connecting vectors with start xy and end xy coordinates. Polygons are described by a series of vectors enclosing the data. So this is another example of the same, that is vector and raster converted by real world. We can see there are tables called raster data attributes and vector data attributes at the bottom of the slide. Attributes are stored in table format, which is known as geodatabase. These tables contains information such as graphical coordinates, name of places, area of place, etc. Each feature, that means point, line and polygon, represents a record in attribute table. Attribute values are stored in RDBMS, which represent record of each feature. As we know, we are using GPS. That means it involves coordinate systems. To spatially derive at the location, two dimensions are required, which are indicated as latitude and longitudes. These are indicated as decimal degrees. Let us say latitude. Its reference datum is a equator. Positive is north, that is 0 to 90 degree, and negative is south, that is 0 to minus 90 degree. Longitude, reference datum is the prime, that means Greenwich UK meridian. Positive is east, that is 0 to 180 degree, and negative is west, that is 0 to minus 180 degree. This longitude and latitudes are represented by degrees, minutes and seconds. So decimal degree is equal to DD plus mm divided by 60 plus SS divided by 3600. So if I want to indicate coordinates of Delhi in decimal degrees, 28 degrees 36 minutes 50.181 seconds north on latitude and 77 degrees 12 minutes 32.476 seconds east on longitude. There are two coordinate systems which are most commonly used. One is universal transverse marcator and straight plane coordinates. These are projections of the curved surface of the globe on plane surface. UTM, Universal Transverse Marcator. This is preferred coordinate system with distance unit meter. This gives two-dimensional locations on surface of the Earth. The UTM system divides Earth in 60 zones, each being a 6-degree band of longitude. UTM position is specified by number of zone, north or south of the equator, east and west of the central meridian of the zone. Distance are in meters. Coordinates are referred to as northing and easting, etc. So it represented as N, the value, comma E, the value. That means northing XXXXX and E YYYYY. There are two datums, reference planes. North American datum of 1927, that is NAD 27, replaces by NAD 83 now, and World Geographic Reference System of 1984, WGS 84. Datum is reference plane which are commonly used to make projections. WGS 84 is used worldwide. UTM coordinates with reference to WGS 84 of Delhi are 43R easting 715.982.29 and northing 3167209.19. So the conclusion is GIS has proved to be a really helpful application. Its evolution with the changing times has been totally progressive. With the changes in the latest hardwares and the softwares, GIS will be used for the best of its purpose. The ability of applied research to create sophisticated maps has been profoundly enhanced by using geographical information system. GIS allows users to create, collect, analyze, and visualize data in an integrated database for use in a wide array of disciplines. Thank you so much for watching this video.